In this video, I'm going to go over the trig functions that we have talked about previously. So we have sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So some of you might be like, well, what does that even mean? So let's kind of go over what that might look like if I'm looking at an image similar to this. You should note that when we're talking about trig functions, they're always going to be pertaining to right triangles. So you should always have a right triangle for these. Those are the ones we're focused on right now. So if I'm looking for sine, which by the way, we write it as SINE, sine, but sin is the short. So we're just saying sine still. It's still sine. So sine of my angle A is always going to be my opposite. This is my opposite over my hypotenuse. So this is my opposite over my hypotenuse. And in this case, that would be A over B. So I'm going to write the fraction as A over B. In this case, you should note that anytime we're looking at a right triangle and we're talking about a hypotenuse in particular, hypotenuse is always going to be the longest length. So this will always be your longest length no matter what. So that's a good indication to help you kind of orient yourself. Another thing you should note is that your hypotenuse is always opposite of your 90-degree angle. So this angle is always going to be the biggest one. This is the longest. That's why they're opposite of each other. So if you drew a line from here to here, it might help you remember that this right here is your hypotenuse, so the longest length. The next one we have is cosine. So when I spell it, it's co, but with sine. And this is adjacent over hypotenuse. So when I'm coming from angle A, my adjacent is next to. So as a reminder, adjacent means next to. So it's right next to the angle. So in this case, if I'm looking at my adjacent over my hypotenuse, so I'm going to write adjacent over hypotenuse, I end up with C over B. And again, notice that B for both of these values is going to be our longest length. So our longest length will always be in the bottom for sine and cosine. Tangent is the one that's kind of special in that sense, is that you might have a longer length on top or on the bottom. It just depends on what the opposite and adjacent are. So when we're talking about tangent, I am talking about opposite over adjacent. So in this case, my opposite is A, and my adjacent is C. So those are the ratios that when we were talking about finding a ratio of it, that's what we're looking for. So we want a length divided by a length. And if you were to convert that into, say, a decimal, in the calculator, you want to write whatever the top number is and then divide it by the bottom number, and that should give you your ratio. So the next thing I'm going to do is go over a few examples. These should be kind of familiar to you up until this point, but just in case you need a refresher, this is what it's there for. So the first thing we're going to look at is writing ratios. And this way you'll be able to see it given numbers. So you'll actually see some values to this. So everything depends on where or what angle we are coming from, right? So I want to find the sine, cosine, and tangent of Z. So if I'm coming from angle Z, it might be easier for me to circle the angle that I'm coming from so I remember exactly where I'm coming from. So sine, like we said, is opposite over adjacent. So what I'm going to do is, since I know I'm coming from angle Z from all of these, I'm going to just label these as opposite, adjacent, and hypotenuse, so that way I can keep track of everything. So my opposite of Z, if I were to draw a line through it means that 16 is my opposite. This right here, 30, is my adjacent. It's right next to it. And that means the opposite of my 90 degrees right here is my hypotenuse. So I know that sine is opposite over hypotenuse. So I'm going to come over here. Opposite is 16 over hypotenuse is 34. Now, when it's asking you to simplify your fraction at any time, that means we want to find what is pull out the greatest common factor. So looking at this, I think they're both divisible by 2. So I'm going to divide them both by 2 to simplify it, and I get 8 over 17. And then if it asks you to put it into a calculator, you would just divide 8 divided by 17. So that would look like 8 divided by 17 in a calculator. Make sure you guys read directions. If it asks you to round to the first decimal place, round to the first decimal place. If it asks you to round to the fourth decimal place, make sure you round all the way to the fourth decimal place. Make sure you're reading those directions. It's super important. So the next one we have is cosine z. So cosine we know is adjacent over hypotenuse. So that means I'm going to come here. Adjacent is 30. My hypotenuse is 34. And I want to simplify this. So just based on what I can tell, I think it's divisible by 2 at least, which gets me 15 over 17. And then again, if I want to put it into the calculator, this is 15 divided by 17 to get you a decimal answer. The last one is tangent z, which means that I have opposite over adjacent. So I'm going to come over here. Opposite is 16. Adjacent is 30. I know they're both divisible by 2 at least. So I get 8 over 15. And again, if I want to put it into the calculator, this is 8 divided by 15. So make sure you have that. So once we go to finding a side length, this is where it gets super important to make sure that your calculator is in degrees and not radians. So you need to make sure that the calculator you're using, whether it's on Desmos, whether it's on using like a Google calculator, anything like that, make sure it is in degree mode, DEG. That is super important. Otherwise, you will not be getting the right answers. You should never have a negative answer in these. So that's a good indication that something isn't quite right. So when we're finding the missing side length, I need to figure out, am I using sine, cosine, or tangent? And then I need to set up the correct proportion and proceed from there. So if we're looking at the first one, I'm coming from this angle here. The information I'm not given my opposite, but I am given this adjacent and the hypotenuse. So it's best to kind of start out by labeling everything, and it'll make it a lot easier for you. So since I have adjacent over hypotenuse, I want you to take a second. You can pause if you want. Which one would I use? Sine, cosine, or tangent? So if we think about it, which one has adjacent in it? Well, that's cosine or tangent. And then which one has hypotenuse also in it? That just leaves us with cosine. So that means I'm going to write cosine of 25 degrees because the degrees is what's always going to go here when I'm talking about this function. And then I'm going to say that is equal to adjacent over hypotenuse. So 14 over x. So take a second and think about this. What we are saying is that sine, cosine, and tangent are functions that represent a ratio or a fraction between the different side lengths of a right triangle. That's really what we're representing here. So when we're looking at this, we're trying to solve now for the missing side length, given that we know the ratio and we know a side length. So from here, I'm going to put this over 1, and I'm going to what we usually call cross multiply. So I'm going to cross multiply like this, and I get x cosine 25 is equal to 14 times 1, which is just 14. So from there, I need to get x by itself. So this is a times right here. I need to get x by itself. Notice that I'm not going to put cosine 25 into the calculator just yet. The reason I'm not doing that is because it's not going to give us an accurate answer if I proceed that way. The best way to do it is to keep it in the form it is until the very end. So from here, x is being multiplied to cosine 25, which means I'm going to divide to undo that. So divide both sides by cosine of 25. From there, that means that this becomes 1, and I'm left with x equals 14 divided by cosine of 25. So in your calculator, it should look like 14 divided by cosine of 25. That is what you should be putting into the calculator. And when I put that into the calculator, I end up with approximately 15.4, depending how you round it, or 15.5. So if I were to round it, that's what I would get. So now I'm going to move on to the next one. So again, I have to determine, is it sine, cosine, or tangent? So let's label everything. I'm coming from this angle. This is my opposite. From my 90 degrees, that means that this is my hypotenuse and that this is my adjacent. So the information I'm given is opposite and hypotenuse, and I need to determine which one has opposite and hypotenuse. So the two options that have opposite are sine and tangent, and then opposite and hypotenuse means that it is going to be sine. So I'm going to say this is sine of 37 degrees, which is equal to my opposite over hypotenuse. Now pause for a second and notice that this setup is slightly different than the one in A. You can see that x is in the numerator in B, whereas it's in the denominator in A. So we're not always going to have the same exact setup every single way, and that's okay, but you got to make sure you're paying attention to that. So from here, again, I'm going to put this over 1. I'm going to cross multiply, and I get 13 times sine of 37 equals x. So in the calculator, I'm literally going to do 13 times sine 37. And when I get that, our answer ends up being about 7.8. So if it's rounded, 7.8. All right, so we're going to go to the next one. So again, checking to see what angle it's coming from. This is my opposite. The opposite of 90 degrees right here is my hypotenuse, which means that this is adjacent. So I'm given my opposite and my adjacent, which means that this is tangent. So I'm going to use tangent of 16 and use opposite over adjacent. So again, I'm going to put tangent over 1, and then I'm going to cross multiply, which gets us x times tangent of 16, which is equal to 18. X is multiplying tangent, so I need to divide by tangent 16 on both sides. Again, I'm waiting to the end to do anything with the calculator, and this becomes 1. So we get x equals 18 over tangent 16, and when we put that into the calculator, we should get, let's see, and I'll show you how I put it in the calculator here. So I have a different one, and how I would do that is 18 divided by tangent 16, and that gets me 62.7734, da 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 da. If I want to round it, this becomes 62.8. All right. So lastly, the other topic we need to go over is inverse functions. So I'm going to flip over to the next side and we can take a look at some examples of inverse. When we talk about inverse, we're talking about finding a missing angle. So we are given the side lengths, but we're not given the angle that we need. And when we're doing the inverse, we're using these side lengths to find out what that angle is. So we're using that ratio that's given between those two side lengths to inform us of what that angle could be. So when we're looking at this, again, we have to determine, is it sine, cosine, or tangent? So for this one, if I'm coming from this angle, this is my opposite. Opposite of 90 degrees is my hypotenuse, and this is my adjacent. So I'm given opposite over adjacent, which means I'm going to be using tangent. So instead of being able to do tangent of some angle is equal to opposite over adjacent, which is 50, that means that I actually have to use the inverse. So in your calculator, you have to put in inverse. So in inverse, we have tangent inverse and whatever the ratio is right here. So 112 divided by 50. And when we put that in the calculator, we get 66 degrees. And then we're going to go to the next one. So same idea, we're going to label it again. Opposite is over here from the angle that's in question. Adjacent is next to it. Hypotenuse is always opposite of the 90 degrees. So that means that I have adjacent and hypotenuse. So I'm going to use cosine. So the inverse of cosine, adjacent over hypotenuse. If I put that in the calculator, we get 16 degrees. And for our last one, we're going to do the same thing. We're going to label our opposite from our angle. We're going to label our adjacent, which is our next two, and our hypotenuse, which is across from our 90 degrees. Notice we have opposite over hypotenuse, which means that we are going to use sine. So sine inverse of opposite over hypotenuse in our calculator will get us 64 degrees.